Thank you. Thank you, everyone. Hello, everyone. So One Commons and Unfurl, it's a brand new open source project that I've been working on. So just getting started. And what Unfurl is a tool that makes it extremely easy to deploy open source applications onto your cloud platform, onto your cloud infrastructure. And I want to talk a little bit about the motivation behind it. So we have this vision of creating a free and open cloud. And what that, for us, that is, those are open source cloud services that you control and you get to run on your own cloud accounts, on your own choice of infrastructure. And why is that important? Well, everything is moving to the cloud. We all know that. No one wants to run their own software. Nobody certainly doesn't want to run their own hardware and servers. Cloud makes it so easy to get started. You have usage-based pricing, minimum upfront costs. So it's really easy to get started, but a lot of open source is being left behind, and this is becoming more and more of a problem for lots of open source software, that there's just thousands of applications. They're not really in a position to create their own SaaS service. They're not going to be on the big cloud providers, product catalogs. And we've probably seen all the news stories about how these big cloud providers are undermining traditional open source business models. And so instead of this easy click through you get with a SaaS service, most people, to deploy open source software, you have to go follow a bunch of manual steps in a README file on the site. And so those are the challenges they face. And they also don't have a lot of information on who their users are and how their users are using it. So these are the things we want to try to fix. And so that leaves developers in a quandary, because almost all complicated applications you're building, they rely on open source software, they rely on open source servers, infrastructure like databases, et cetera. And so you can integrate that yourself and you can run it yourself, but it's hard to get started. There's complexity. You have to usually do some sort of DevOps process, but you get all the benefits of open source and being able to customize it and add your own proprietary value add. Or you could switch to you'd use a proprietary SaaS service if it's available. It probably isn't available, but if it is, you could do that. But then you have the downsides of you get vendor lock-in. You don't have the flexibility. You usually have a one-size-fits-all approach with these services, and the long-term costs end up being higher. So, but what if you could have the best of both worlds? What if you could get the ease and simplicity of the cloud, but also not give up the freedom and control you get from open source? And so that's our vision of an open cloud service is. And one way to look at it is to think of it as an overlay over your cloud provider infrastructure that you're using. So your apps can deploy these open cloud services on top of your cloud provider or other services that you're integrating. And so if you step back and think, what do you need to do for that to exist, to make this a reality? Well, one, they have to be easily reusable and remixable in the same way you can do that with open source. They can't rely on any particular cloud provider's proprietary APIs or infrastructures. You need portability. Security is paramount, because without security, you can't have openness if you can't trust the software you're using. And also, to have something that is independent, cloud independent and reusable and remixable, you need some sort of decentralized identity that's not tied to where the actual where that particular thing is running, the service is running on. And if you're ever going to get adoption, you need to make it usable and have some sort of web-based interface in the same way any big cloud provider provides. And so those are the requirements that kind of driven the design and implementation of Unfurl. And so Unfurl is really the beginning of this roadmap to building this out. And so it's a command line tool that you run yourself. So there's no server agent involved. It's a tool for deployment. It it's open source, of course. It saves everything that you describe and how it works is all YAML-based configuration files. The vocabulary is based on this standard called Tosca, which I'll talk about in a minute. And it stores everything in Git. And so that gives you this decentralization, this reusability, this integration with developer workflows. So what that enables is developers, open source developers can easily build these service templates, which are these abstract descriptions of how what the application depends on. It could say, hey, it needs a Postgres database, for example. It needs a compute instance with this sort of capabilities, and maybe it needs to connect to DNS. So the developers can develop these simple abstract descriptions. And then when their users go to deploy it, Unfurl can choose and automate the process of just deciding which actual implementation. So if it's Postgres, if you're deploying onto AWS, and you could use AWS's RDS built-in service, or maybe you want it to be self-hosted and we can deploy it like that, or maybe you want to use another third-party service for Postgres, et cetera. Same thing with the compute. The compute instance can run on a wide variety of different kinds of things as long as it provides those capabilities. And so that is something that hiding that complexity and automating that process is something that really differentiates it from other DevOps tools and processes. And the key technology behind it that enables that is a standard called Tosca. So it's sort of a mouthful. It stands for Topology and Orchestration Specification for Cloud Applications. Today you really only see it being used by large telecom providers, large cloud providers. But what it enables us for an open source project is it enables us to create these abstract representations, and that abstraction allows us to hide complexity. And so you define these topologies, which are these again, this YAML description that describes these node templates, and it's an abstract thing. So users can define all sorts of different kinds of applications and describe what operations you use to actually implement them. And so what that enables is this technology that I was describing before, where a Tosca orchestrator like Unfurl can automatically match and optimize how things are deployed based on the application's requirements on the one hand, and then the user's capabilities of the infrastructure that the users are using. And then the other part of Unfurl is this plugin architecture we call configurators. And so what they enable is you to use the existing DevOps tools that exist today to actually perform these operations, whether it's Terraform or Ansible or just a simple shell script. But again, you're hiding that complexity, so the user doesn't have to know Terraform or get into the details there. And then on top of that, we can build these abstraction installers where these resources know how to deploy themselves in different kinds of environments, like Kubernetes or local developer environments like a Docker engine or a supervisor. It's another thing we support. And so just a big picture of how all this comes together. So again, we talked, there's YAML files, and so there's a service template that is the Tosca spec, and then there's some local information, and then we combine that together into what we call ensembles, which is our representations of these cloud services. And then the Unfurl tool, when it runs, when you deploy it, it builds an isolated environment to deploy in. So we have reproducibility, which is a key requirement to have this open cloud. It invokes these configurators that we talked about. But then one thing it does that stands out from other kinds of DevOps tools is it records the results. So now we have an abstract representation in Git of the status of these resources that's separate from the cloud provider. And that's one of the key ways that we achieve this independence. And that enables us to create these reproducible ensembles where by having an isolated deployment environment and creating an isolated cloud environment that it runs in, we can create these deterministic processes that enable us, again, to create relocatable, open, transparent cloud services. And so just to drill down a little bit deeper, so if you go open up one of these YAML files, there's sections that correspond to these different aspects of the deployment management process. The context describes the local development environment that it runs in, so what tools it needs and what kind of credentials it needs. It can integrate with the secret managers, for example. The spec is the Tosca service template we talked about. The status is, after you deploy it, the actual status of those resources. So now we can do incremental deployments. Now we can do day 2 operations to manage resources after they are run. And then finally, you have a lock section, which describes precisely the versions and digests of what you deploy, so you get this reproducibility. And we can dive into it a little bit more. But so here, just because the beginnings of the YAML we can see here, we'll just go through this quickly. We can see examples of what it looks like, some of the YAML you would see. And then I just want to end with a little sneak peek of the platform we're building. So this is the service that you can deploy, that you can run Unfurl onto. So there's a few really nice visuals, open source visual tools for building these service templates. And so we want to make it really easy for developers to just drag and drop and combine these things. And so we're integrating those tools into our platform here. And then what that enables, and this is one of the key parts of our vision, is that developers can just, once they build these service templates, they can put these buttons on their site. So example, here's a README page on GitHub. So instead of having to follow a bunch of long, manual directions that typically is what you see, a user could just click on this button to deploy the application. It will go to our website where we have a nice visual UI for easily configuring, authorizing us to deploy onto, say Google, to choose a particular set of services you want. And then once they do that, then now the user can both deploy it. And so we can have functionality like, oh, I just want to run this for a week. We'll shut it down so I don't forget this thing that I deployed is running, or other kinds of simple things that provide a lot of value. But it also enables open source developers to get information about who's using their software and how they're using it, which right now is really, really hard for open source developers to obtain. And so finally, I want to end with a question. So Mark Andreessen famously said, software is eating the world. And we have seen how open source has become the dominant methodology for creating software, especially at the infrastructure level, in the middleware level. And we've seen how cloud computing is really displacing software and everything is moving to service. So the question is, what if you could combine them both? What if in the same way anyone could reuse and use open source software, anyone could reuse and remix and fork actual cloud services? So what would happen? What would happen in that world where you could do that and you could have all these things combined? So that is the question that we think there's all sorts of amazing possibilities would happen if that existed. And so that's it. So thank you.